Good afternoon, everybody. Thank you very much for coming. I'm thrilled to be here to talk to you about Lambda at the Edge. And while I know I'm the last thing standing between you and the party outside, I'm really looking forward to spending the next hour talking about what we've been spending a lot of time building with the Lambda and CloudFront team. So today, in order to contextualize Lambda at the Edge, we're going to talk a bit about the AWS Lambda and Amazon CloudFront services individually, because each is its own service outright, but the combination of them is what makes Lambda at the Edge truly extraordinary. We'll walk through a bit about what Lambda at the Edge is, how it works, when to use it, and when it may not be the right tool for the job. We'll do a quick demo of a use case, talk with one of our customers, CloudNir, about how they are going to be using Lambda at the Edge to make their application better. And perhaps most importantly, tell you, our customers, how to get started with Lambda at the Edge. AWS Lambda is the evolution of cloud compute towards serverless. But serverless is defining something as a negative by what it's not. So let's talk a little bit about the root of that term to understand truly what it means. Around 10 years ago, AWS released Amazon EC2, which was revolutionary in terms of giving customers the ability to deploy servers virtually on demand in the cloud and paying only for what you use. So with the infrastructure being within the AWS cloud, you could spin up 1 or a dozen or 1,000 instances on demand when you need them. And perhaps most importantly, when you don't need them anymore, just send them on their way. With these instances, you could deploy one or many applications on them, and providing you with the ability to build out entire applications in the cloud without actually having to build any of your own physical infrastructure. But these applications would generally perhaps have multiple interrelated dependencies and create management headaches and challenges when you have to worry about all sorts of cross-application dependencies. So then we evolve to containers, which gives you the ability to, within instances, define different levels of isolation within which you can run your applications. You could define multiple containers within an instance, group them however you want, and be able to simplify that management. But under the covers, you're still managing fleets of instances, and you still have potentially a small or potentially a large number of idle resources that is certainly less than when you're running your own infrastructure, but more than zero. And when we feel we can do better somewhere, even though we've already made a serious leap, we really strive to do better. This is where serverless comes in. Werner, when he announced, was talking about AWS Lambda at the keynote, used a really good metaphor that I hadn't heard regarding, first of all, how the cloud allows you to think of your herd of cattle. So then, if you have one that's not doing too well, you put it out to pasture and get another one. But with serverless, there are no cattle. It's just the herd. And all of that management of the infrastructure and instances and dependencies is taken care of by AWS. You run multiple applications in response to events, and you are fully isolated from all other customers so that you are fully protected and your data is secure. And add more animations there. So it is serverless computing, but I really like to think of it as event-driven computing because the model of serverless is very different, right? When you set up servers to run your application, you're thinking about in the vast majority of cases, handling inbound web HTTP requests. There are certainly others, but the vast majority will be HTTP requests. And your application is then serving in response to those inbound events. But in the cloud, especially with a cloud as rich as AWS, there are so many more things that can generate events than just inbound web requests. Now, one of the most common uses of AWS Lambda is as a producer for API gateway. So where you, instead of having your fleet of EC2 instances behind an ELB handling web requests, and then having it be idle when it's not handling web requests, you instead have Amazon API gateway that would call AWS Lambda to perform a function. But those aren't the only events. You can perform a log analysis when a file is put into an S3 bucket. Whenever a row is updated or inserted into DynamoDB, you can do something analogous to an SQL trigger that will allow you to perform additional action on the database, or perhaps do some sort of external operation. As I mentioned, API gateway, mobile backend calls. You can also call AWS Lambda directly. So there's actually an AWS API where if you have a server that wants to, or an application that wants to call an event, you can call them explicitly. And as of today, in response to CloudFront requests, which is fundamentally what Lambda at the Edge is. We'll talk more about that later. So the benefits, giving you no servers to manage, continuous scaling, and never paying for idle time. The cost models for AWS Lambda, which are the same as Lambda at the Edge, involve only paying for the actual time and requests that you use. So it's taking those instances that we started with 10 years ago and taking it down to being able to pay literally by the millisecond. But with all of this, it is triggered from within a single AWS region. So this is where the edge comes in. When we're talking about the edge in this context, it is the AWS global network of points of presence, or POPs, that we connect to the backbone of the internet, which is Amazon CloudFront. Amazon CloudFront is a global content delivery network which accelerates your applications and APIs. It's massively scalable and very secure, completely self-service, like all AWS services. We charge the same for HTTP and HTTPS requests, and it's priced to minimize cost and simplify billing. So instead of having to worry about what the peak of your traffic may look like, you pay only for the data transferred. It's also able to deliver all types of content. So it delivers static content, which is what you would tend to think of when with a content delivery network. But it also delivers video and dynamic content. The notion of delivering and accelerating dynamic content and user input is one that is not generally thought of as an advantage of CDNs. But the way that CloudFront is built is that we are able to significantly accelerate API and dynamic content requests, because from all of our networks of POPs, we maintain connections to the origin. So when a customer is connecting from, say, India, who would want to connect to an origin, would be connecting to an origin in, say, Virginia, rather than having that 200 to 300 milliseconds of round trip time to negotiate the connection, to bring up TLS, they would only have to go to one of our several points of presence in India. From there, we would have an already cached connection to the origin, so that connection negotiation will take a small fraction of what it would take going to the regions. And as I mentioned, SSL. So all of this is possible without changing your back end. And this is, again, one of the areas where Lambda at the Edge gets to be very powerful, because you're able to put CloudFront in front of your application without making any changes to it. It handles the dynamic content, it handles static content, and all of that can be done by just configuring CloudFront to be the front page of your property. But imagine if taking all of these points of presence and being able to accelerate connections and deliver dynamic and static content. Imagine being able to run it from 68 POPs or 9 regional edge caches across 21 countries in 5 continents. So putting this all together is where we get to Lambda at the Edge. It's an extension of AWS Lambda that allows you to run Node.js code at AWS global edge locations. It is a Turing-complete environment allowing you to execute arbitrary code and import third-party libraries and write code in, say, your home region in Northern Virginia, and then deploy it seamlessly across all of our edge locations with the click of a button. Writing your code once, we will push your custom code to edge locations very, very quickly, generally within about 1 minute. And then when customers connect from Australia or South America or India or Central Europe, they're running their AWS Lambda at the Edge code at these facilities that are very close to them, all without any additional operational burden of managing any sort of replication or content distribution. So looking at this from a more detailed perspective, this is happening within CloudFront. So this allows you to extend the functionality of your application to the edge. The events that CloudFront generates currently are 4 events. Viewer request and viewer response are generated whenever a viewer asks something of CloudFront. Now, in terms of Lambda at the Edge, the assumption is that you would not generally be executing Lambda at the Edge for every request. You certainly can, but they are defined on a per cache behavior basis. So data that you would want to change in response to a viewer request could, for example, be some sort of end-user authentication, cache key modification, or perhaps something that you want to pass on in as a parameter to querying the cache itself. Viewer response would be more of end-user personalization. So after the content comes out of the cache and is being ready to be delivered back to the viewer, you could personalize that content. On the origin side, the origin request and origin response events are triggered when a request gets through the viewer stage due to a cache miss. So in the case of a cache hit, the only 2 events that would trigger would be a viewer request and viewer response. Doesn't really get that far. But in the case of a miss, it would go through the CloudFront cache and say, okay, now we need to get content from the origin. So those sorts of use cases would be things such as content-based routing to the right origin, perhaps some sort of custom origin authentication, manipulating URLs. So in the case of a pretty URL that comes in and needs to be more complicated to get, or different to get data from the origin, it could be changed in that way. And integration with legacy systems. In terms of the response, after the request has come back from the cache, the customer is you are then able to manipulate that response to potentially change the headers, modify the response before caching it, and then before it's then handed back to the viewer to then hand back the response. The important thing to note is that for each cache behavior that you have in your CloudFront distribution, you may define 0, 1, or some or all of these events to be handled. So it is possible that for a request, you could fire 4 events and have 4 separate Lambda scripts if your use case calls for that. But let's get to some of the things that you could actually do with Lambda at the Edge. So one of the use cases that we've heard a lot from our customers is content customization. So being able to identify a user's location or what sort of device they're on, and potentially either customize the object being requested from the cache, or changing image sizes and things of that nature. Likewise, changing the request or the objects being returned based on the device properties in terms of screen size. Perhaps the location of the device could indicate that you would want to send back different content. Furthermore, you can perform visitor validation. Bots can be both good and bad. Search engine bots, for example, are things that you might want to make sure you hand back exactly the right content to make sure your content is being indexed as you want it to be in the search engines. Likewise, there are bots. Good. There are bots that you might not want to be getting into your system, and then you could display a CAPTCHA. Likewise, session validation. If you want to have content that is secure, you want to make sure that only customers with a certain session identifier or key can access, you can perform token or other forms of authentication based on those data. Another use case we had from customers is for customers who have content, static image content that they serve and then derive ad revenue from. So a user might find an image and just copy the actual image URL and try to share that image. But then that image wouldn't actually be revenue generating for our customer. So being able to detect when an image is being requested that is not actually supposed to be served in isolation, and then rewriting and redirecting to an actual HTML page to create the proper framing and structure of the page. Also, pretty URL rewriting is something that can be done through Lambda at the edge to avoid revealing origin data structure, and or just to shorten URLs and make them easier to share with end users. And the final use case I'd like to talk about before we get to our demo is A/B testing. This is one we hear a lot from customers. They want the ability at the edge to make a really quick decision about what version of content, or what content in particular, to send to a viewer. And being able to make that decision at the edge, and realize that code's not particularly readable, but we're definitely going to be sharing some examples with you. It gives you the ability to set cookies and assure users see the right versions of content. And I believe that a demo of this use case is coming up right now from Shabam. Shabam, over to you.
Welcome, everybody. I'm so glad that you could take time and attention today to come and attend our session. All right, so let me try to plug this in. That seems all set. So over the last 15 years, we have seen content distribution network make internet faster by starting to cache internet assets, images, videos closer to the end users. But not so much has happened in the dynamic content delivery. When it comes to personalized content and delivery of dynamic content, that is still dictated by the speed of light. Well, Lambda at the edge brings compute closer to the end users. So your users who are sitting in Seattle are being served out of data center or regional edge locations, as we talked about for AWS, right in the heart of Seattle. For users who are in IID are being served out of the edge location, which is in Northern Virginia. So we are going to take a simple example today of building an A/B experiment application. Have people heard about A/B experiment? Anybody new to the idea? Fairly educated audience. But I'll repeat for the benefit of who do not. The idea is very simple. It's A/B experiment is a mechanism for us to evaluate the effectiveness of few variants of a website. And so the intention is that we serve different variations of websites to similar audience, and then we study their behavior and responses to understand what is serving their needs better and what is serving our customers' needs better. We'll pick a very simple example today. We'll try to build an application which will be powered by S3, which is a simple file storage web service. We'll put CloudFront in front of it. We'll pick very simple configuration. It'll be a see-through, like essentially CloudFront receive requests, and it's going to be a plain vanilla configuration. And we'll try to build this dynamic logic of A/B testing through compute at the edge. So let me point out there are two important aspects to applications when we are doing A/B testing. And the first one is that for the first time, if a request visits our page, we have to toss a coin and assign him to one of the treatments. That's one of the experience we want to offer him. And subsequently, if a user revisits, then we have to serve him the same content. I think that practically summarizes the scope of the problem we are trying to solve. So let me show you the simple setup between CloudFront and S3, and then we'll jump onto Lambda at the edge and we'll walk through the script and see how that script solves these two problems which you discussed. All right. So this is our S3 bucket, and I don't think it's very readable, so I'm gonna zoom in. Is that good? Yeah? Awesome. So this is our sample S3 bucket. There are some assets. There's a store which has some fonts in there. And I've created a folder called experiment treatment images. And if I go inside this, our intention is that to any for unique visitors, we want to offer one of these cat images: cat angry, cat Batman, cat fat, cat gravity. So we'll see what comes up today. And just for some variety, we've thrown a giraffe and a seal at the bottom. We'll see if we get lucky. We have also created a CloudFront distribution. And so if you remember, our bucket was store.myname.name. And this is a very simple CloudFront distribution. For those of us who are not familiar with CloudFront, as we said, content distribution network, and you can pick an origin you want to relay and cache the content which is coming on at the edge. So in this instance, we have selected the origin, which is our bucket, which we found in the S3 folder. So just to demo this simple setup, the way it looks like is if we go to our CloudFront distribution, which is by this name, and if you see in our home folder, we had, say for example, jellyfish. So if you go and type, apologize, the address bar is not very readable, but if I type jellyfish, you get jellyfish. So it's essentially sends your request all the way through what CloudFront receives, relays it all the way to S3. So this is where the interesting part comes in. So I've done two things here. I have created two Lambda functions. I've created the first Lambda function to respond to the viewer request. And these are the 4 events which Alec was just mentioning in his part of conversation. So viewer request event is when an end customer sends a request to CloudFront. Right before it arrives at and it is processed by the cache, it is going to invoke an event for Lambda. And that Lambda event is going to look something like, okay. Let me pick this up. This is something like this. I'll see if you guys can read it. I'll try to increase the font. So this is what the viewer request event looks like. So essentially, if a viewer sends a request to CloudFront, it's going to generate, invoke a function which is going to have the property of the distribution which it's being called for. It's going to have the URI for which the customer is calling. It's going to have all the different header properties, including user agent, host header, and all the cookies which are part of the request event, right? Okay, so let's see how we can solve our problem of first randomly picking a cookie. We're going to use cookie, I'm sorry, that's another aspect. We're going to use cookie for the session stickiness. So cookies is another browser concept, and essentially each of the websites can use this as a mechanism to track users across a single session. And as we get inside the details of it, for those who are new, we'll try to explain that. All right, so let's get to the juicy part. All right, so I've created a function. I've called it reinvent viewer request cookie trail, just like that. And so this is what the function looks like. I'm going to try to expand it all the way so everybody gets a nice view. All right. Is that readable, everybody? Yeah, one in the back. Cool. So we just saw the structure of the event, which looks something like this, right? So to solve a problem, what we're going to do is we're going to see if this is a returning user first. So we're going to try to find the cookie. And if the cookie is already assigned to that user, that means he's a returning user. And we have to return the same treatment or the image which he was served the last time. And so that is what the first part of the problem solves. So I'm going to briefly walk through this code and explain you. So these are all the treatment groups which we saw. And then this is the cookie name which we have decided to set within the browser to track the session. This is the S3 folder, which we saw in the S3 console. And if you realize, this S3 folder, actually, I'll save that for a little later. Then we try to read the request variable from the event object. We try to read the cookie out of the event object. This is regular JavaScript. And this is where the interesting stuff happens. Now we're going to loop through all the cookies which are part of the request which we received from the customer to find the cookie which is relevant to us. So that's the cookie which we are using to track the user session. And we decided to use X reinvent bucket to bucketize different customers across different treatment groups. So we loop through each of the cookie, which is part of the via request. We trim the cookie for any external spaces, and we see the cookie which matches the name of our experiment. If we see a cookie which matches the name of our experiment, means that is the cookie we are trying to track, we'll get the cookie value. Then we'll see if that cookie value is valid or not. So we'll see if that cookie value exists in all of the groups which we defined on top, which is all of the cat angry, cat bad, cat fat groups which we defined. And if that is true, so it's a valid cookie, the cookie exists, the header is right, and it's one of the buckets, we're going to change the request URI. And the request URI is going to be the S3 bucket folder, which was our experiment treatment images. So in some ways, this hides the entire bucket and our folder and our origin directory structure from the end viewers. And we are going to append the path name .jpg. So essentially, if somebody's coming back from a cookie cat Batman, then we serve him a Batman cat. We'll see what we get today, so that's still a surprise. If we do not see any cookie which was set, or then we come here, we try to throw dice, and we try to randomly select one of the groups which we want to assign to this customer, and change the URI to point to that new experience which we want to offer to our unique visitor. Does that make sense so far? Yeah, people are with me? Cool. Awesome. So what did we do next? What we did next is we associated this function with CloudFront distribution. So I'm going to try to create a new association just to demonstrate how it works. So if you have written this function and say, for example, you have a CloudFront distribution which you want this function to handle all the incoming via requests, you would come to the trigger function here. You'd pick CloudFront as the event source. It's going to refresh this page. And I'm going to pick, say, for example, reinvent. I'm going to pick some distribution. I'm going to pick some cache behavior. And I'm going to say, on all the viewer requests, invoke this function before you do CloudFront processing. And if you submit this, it should start syncing. So I've just associated this function with another distribution. While that syncs, we're going to use the original one which I created before the session to continue the demonstration. All right, so that is one function. I've also created another function, and that is, so if you noticed, if a customer has set his cookie, we can retrieve the cookie to send him over to the right, to serve him the right image. And if the customer does not have a valid cookie, we are going to throw dice and select an image to serve him, but we do not set the cookie yet. Because setting a cookie is an operation, or it's a valid header only on the response. So we have created another function here, which is viewer response. And what that does, it's a very simple function. It has the same cookie name, which we want to set. So when it comes back, our viewer request function understands it. And it uses a metadata header, which is content of our object. And if that metadata header is present, it's as simple as that. It sets the cookie value to that metadata header. All right. So the three pieces of the puzzle I'll complete. So we have a static S3 website, which has a folder which contains all the treatment we want to offer our customer. We have a CloudFront distribution, which relays all the requests it gets back to the origin. And we have two Lambda functions. The first Lambda function is going to be triggered on the viewer request arrival. The other one is going to be triggered on the viewer response. Let's see if this works. This was working a little while back. It's going to be embarrassing if it does not, so we're going to try it out. All right, so I'm going to form the URL. And so this was the viewer request. I'm going to copy the URL which we decided. This is the, all right. Okay, so let's see what happens. So we're going to open some browsers and see with different browsers what comes up. Okay, so for visitors from Chrome, okay, so this is what they get. And if you refresh it, it should remain the same. So we got a cat, which is stuck. I think this is a cat drunk or something. We'll figure that out. And if another visitor, unique visitor, who's from a different, it could be from a different device. In this instance, we are using browser for a proxy. Comes up and sees, they're going to see, say, cheese. So they get a seal. So we got some variety. And if you refresh it, the content essentially should not change. So behind the scenes, what is happening, let's see. is if I inspect this, and this is where Chrome breaks because even if I zoom in, it would not zoom in these subheaders, but I'm going to read it out for you. So if we refresh this image, what is happening is, I'm so sorry. Okay, let me copy this out onto our image, and then we can read it from here. So this is the response we received from the viewer. So this was cat stuck. And what happened essentially is, after the image was fetched from the cache, we inserted this cookie and saying, anybody who's getting this cookie, send them back to the same page. And similarly, if we see the request header, we'll see in the request header, the cookie cat stuck was sent out when the browser sent the request over. I think this is a very simple but powerful example which demonstrates how something as vanilla flavored as just the HTTP file system, which is S3, and very simple configuration of CloudFront can result in dynamic user experiences through our computation which you're doing at the edge. Well, I guess that is all I had for you guys. Thanks a lot for your time and attention. Okay.
Switch back. Nice job, Shubham.
Yeah.
Thank you.
Thank you.
Well, thank you very much. So now you've seen just a very simple but I feel is a good illustration of what you can do with Lambda at the edge. Now, to talk a bit about a less contrived and actual customer example, we have Daniel from CloudNir who's going to tell us about what he's hoping to do with Lambda at the edge. Daniel?
Thank you, Alec. Great work, Shubham. Demo works. This is great. Cool. So I'm very excited to be here today and share CloudNir journey integrating with Lambda at the edge. Well, it wasn't as much of a journey as it was a walk in the park, as you soon see. Now, to tell you a bit, before we jump right in, let's start by telling you a bit about what CloudNir actually does. And we started the company 5 years ago with an aim to provide an end-to-end solution to image and video management. It's a cloud-based SaaS, and we cater web and mobile developers who use CloudNir as core backbone and infrastructure. It's a fully API-based system and completely modular. And by that, we try to cover the entire image management pipeline, starting from upload, storage, digital asset management or media management, and things which are a bit more relevant to this session are the cool stuff, which are manipulation done on images and videos, meaning you can resize, crop, add watermarks, add images within videos, and so on. And we have CDN, which is, we want to deliver those media assets through a CDN, which is an integral part of the system. Now, as mentioned, the system is completely modular, so we have many customers picking and choosing whichever components they want to integrate. We have 160,000 developers who use CloudNir, from small startups to large enterprises. We manage for them more than 11 billion media assets, and we're doing that at a rate of 2,000 transformation and manipulation of those media assets per second. Now, all of those customers of ours, we have many customers like large media sites, publishers, commerce sites, all of those have something in common, which is images. And I want you to take a minute and think about your images on your applications, on your platforms. Think about all of those images and medias that you have, all the things that you left behind coming here to reinvent, all of those applications you need to get back to tomorrow, that work thing that everyone is talking about. So when you think about them, are they loading fast enough? And how would better performance affect your results? Now, as developers, you suddenly have to deal with all sorts of new devices coming to the market. Different resolution, different browsers, user locations, network capabilities, and responsive layout. You want to provide the best experience to your users, but you want to enjoy the benefits of making dynamic decision at the CDN layer. And this is where Lambda at the Edge presents a very good solution where you can easily add actions at the CDN edge using very simple JavaScript. Now, the architecture seen here is very similar to the one that Alex showed before, but to put it into context of media, and let's focus on images, for instance. So you have users downloading images from different browsers, and then the URL of those images, along with some additional information about each specific user, like user agent, image type, and client hits and DPR, is being sent to our code, which is deployed at Lambda at the Edge, where the Lambda at the Edge smartly and dynamically helps us adapt those requests and lets CloudNir generate images on the fly, manipulate them, optimize them, and then we send the best fitting image back to the CNN to be cached. Now, just to share a couple of examples of what we currently have with Lambda at the Edge. So what you see in here is actually a couple of examples. So the first example is dealing with image formats. So as you know, there are many types of users out there who have many choices regarding browsers. You want to serve them the optimal image, but what is an optimal image? I mean, JPEGs are great, but now we have many different other image formats. You have a WebP, which is Google compressed format of an image file. You have JPEG XR. And the problem is that not all browsers support all of those formats. So Chrome won't be able to run a JPEG XR. And if you're running using Firefox, they won't be able to currently handle all of those image formats. So what you have here, if you look at the URL, and it's actually, if you're quick enough to copy it, you can actually start playing with and manipulating the images yourself. So we have the blue writing the URL, resizing an image, but the f-auto marker seen in the URL actually sends a message to our code implemented in Lambda at the Edge so to select the best format of an image. And that format is being sent back to our to the browser, and that you have the result is that you serve the optimal format to best fit the right browser. And what you experience is all of those images are looking great, and since WebP and JPEGs are a bit more compressed, the experience is that you see some saving in file size, which resulting in 30% better save. And the beauty of it is that CloudNir, we didn't have to change our origin code. We just let CloudNir code at Lambda at the Edge help us make those decisions. Second example is dealing with responsive images. And with responsive images, you need to address all of the different devices and browsers out there, and you want to serve the I guess, optimal image to fit the design. But the question is, do you want one image to be served to all different screen resolution, or do you want to generate an image for each screen which is out there, which might be a bit too much? So what's the right balance? And here again, we solved this using modern client hints. And as you can see in the URL over there, there's the W-auto and DPR-auto marker, which again sends request to our code at Lambda at the Edge to generate the best image that fit the actual screen. Not only that, but we have smart algorithms that help us sort of detect and provide a fixed set of pixels so that we won't be needing to generate all of those images. Now, something which is quite interesting there is that Tal, who's our CDO, who's in charge of the integration with Lambda at the Edge, found out something quite funny, which is, developers, usually you address developers as either being lazy or efficient, so God forbid I'll be calling our CDO lazy. But what we found out is that when we had to implement this solution with other CDNs, you had to write hundreds lines of codes of condition and instruction to the CDN. And here we have Lambda at the Edge, which presented a very elegant solution that by using one or three simple line of JavaScript code, we were able to achieve this thing, which is, again, was quite fun to see. Our last example for today is touching quality, image quality. And the cool stuff here, it's not only that we're touching quality, we're actually touching mobile saving data. Now, it's a matter of how do we want to handle poor network connectivity. The Q auto marker seen here in the URL already runs different encoders on each specific image and then creates a degradation of the image. You get a bit of a less of quality, but one that is unnoticeable by the human eye. But the cool feature that we were able to implement using Lambda Edge is actually dealing with mobile save data and with model browsers, and especially browsers of different mobile devices. They have some element which is data save mode, which can be switched on in case of poor network connectivity. And again, I guess it's a compromise between serving a high quality image or sending delivering a bit degraded one, just so that the page upload speed will be higher. And again, in here, you have one URL, which says all users. QAuto just sends us a notion of the quality of the network of the user, and then you serve one URL serving different devices, and the result is, again, decreasing the file size and results in 30% bandwidth save. So these are just some of the examples already live right now with Lambda Edge. And it was very exciting to integrate because it opened up a world of possibilities and opportunities. So, for instance, and I think Alec mentioned some of those in his talk, when you want to add a security layer, you want to block user, you want to via geolocation, IP, or referral, you might want to use third-party data that is collected on the edge to better determine a better way of controlling the quality of images. And the cool part is touching personalization. Now, with personalization, there are some cool stuff that you can do with CloudNir right now. I mean, change color of images and then add text, personalize text, and provide a better experience for the user. So we're very excited with this new technology and with the integration. As I mentioned, URLs are live right now. So when you get back to those web applications, those platforms, make sure to try them out and go experiment. Thank you.
Great, thank you, Daniel. Sure. Okay, now let's get to the final phase. Getting started with the Lambda at the Edge preview. So I think we've covered this all pretty well, but using Lambda at the Edge, you bring your own code, either using existing Lambda functions or writing your own. The programming model will be Node.js, and you can write once and run anywhere in all of our 68 edge locations. So getting started. There's a bit.ly link we have up here. So if you, I know it's not clickable in there, but it's bit.ly/lambda at the edge. I think we tried to put the ad in there, but it probably didn't work, right? Right, Mina? That's okay. And then you will get an email when we have whitelisted your account. That whitelisting process is going to take a couple of days for the time being. So get those requests in. The service limits that are associated with the Lambda at the Edge preview, because remember this is being released as a preview. The runtime is Node.js, triggered by CloudFront events. There are no network connections or disk access or AWS region access or VPC access for the time being. The timeouts are something that I wanted to spend a couple seconds talking about, more than a couple milliseconds. The functions in Lambda, those tend to take seconds to minutes, things like log processing, and they can be fast, but there's a lot of use cases for longer ones. But the whole point of running something at the edge is for it to execute quickly. If something's going to take longer than 50 milliseconds, probably might as well do it in the region anyway. The one power level or memory footprint we're going to support for the time being per VM is 128 megabytes. Fortunately, the Node.js runtime tends to be pretty small, so that should give you a good amount of space to work with your application code. And your package size can be 1 megabyte. Whoops, wrong way. The pricing schemes that we're using for Lambda at the Edge are the same model as Lambda. The prices are slightly different, 60 cents per million function executions, and just take my word for it what the number is for the per second of execution time. So for an example of 10 million executions, with each one being roughly 50 milliseconds, that's going to translate to about $9.13 per month. But the final thing that I want to leave you with is we've talked about use cases that we've thought of, and Danny was gracious enough to come and spend time telling us how he and CloudNir are using it. But we have a ton of additional functionality that we want to build for Lambda at the Edge. But we haven't quite figured out what order we want to build things in, and we really want to hear feedback from all of you about what you like about Lambda at the Edge, which is great, but what the most important things that are missing from it that you think we should be focusing on in terms of development. This is, I think as was said multiple times during the keynotes, and it's true, is that over 90% of our roadmap items are driven by customer feedback. So really want to hear from you how your experience is with it, and the sorts of use cases that you can solve, and the sort that you want to solve, but we need a couple of extra features in it. So thank you very much, and please don't forget to complete your evaluations.